If you want to draw more complex graphics and you want to update those graphics frequently, then you can do your drawing with a canvas. Now, as I said earlier, a canvas is a kind of context or mechanism for drawing to an underlying bitmap. And you can access a canvas either through a generic view object or through a special view subclass called surface view. Usually, you'll draw through a generic view when your updates are less frequent. And if you take this approach, your application should create a custom view subclass, and then the system will provide the canvas to your view through a call to its onDraw method. If instead, your application needs to frequently update its graphics, then you might consider drawing through a surface view. With this approach, the application creates a custom surface view subclass, and it will also create a secondary thread with which drawing operations on that surface view will be performed. At runtime, the application can then acquire its own canvas and therefore exercise more control over how and when drawing occurs. This next example application is called Graphics Canvas Bubble. And the idea behind this application is that it will draw a view and then update that view, but the updates are somewhat infrequent, about every second or so. So this application has an internal thread that wakes up once every second or so and moves the view and then uses a canvas as it redraws the view in its new location. Let's see that in action. So here's my device, and now I'll start up the Graphics Canvas Bubble application. The application starts up with the bubble drawn at a randomly selected location. And every second or so, you can see that the bubble is erased, moved, and then redrawn in its new location. Let's look at the source code for this application. So here's the Graphics Canvas Bubble application open in the IDE. Now I'll open the main activity. Here you can see that the application loads a bitmap from the resources directory, and then it uses that bitmap to create an instance of a custom view class called BubbleView. Next, the code adds the BubbleView instance to the layout, and then it creates and starts a new thread. And that thread goes into a loop, and on each iteration, it calls the BubbleView's move method. Now, as we'll see in a second, this method changes the BubbleView's location and then returns true or false depending on whether the BubbleView's new location is or is not still visible on the display. Next, the code calls the view class's post-invalidate method. This method tells Android to redraw this view. And after that, the thread goes to sleep for a second before waking up and starting the process one more time. Now, I'll skip over most of the details of how the BubbleView moves itself, and I'll focus instead on how it gets redrawn. So when the drawing thread calls the post-invalidate method, this tells Android that the BubbleView thinks it needs to be redrawn. If so, then Android will eventually call BubbleView's onDraw method, passing in the canvas with which the BubbleView is drawn. Let's look at that method. And as you can see, this method takes the canvas passed into it and calls its draw bitmap method, passing in the bitmap to draw, passing in the top and left coordinates of the position at which to draw the bitmap, and finally passing in a paint object that defines style parameters for this drawing operation. Now, if we'd like to really increase the frequency with which we're redrawing the bubble to make it more smoothly glide across the display, then we might want to use a canvas and a surface view in order to do that. And as I mentioned earlier, surface views need a separate non-UI thread in which to do their work so that surface view operations won't interfere with UI thread operations. So let's talk more about the surface view class. A surface view manages a low-level drawing area called a surface. And this surface is a dedicated drawing area that is positioned within the application's view hierarchy. To define a surface view, you need to create a custom class, which is a subclass of surface view. And this custom class must also implement the surfaceHolder.callback interface. To use this new surface view, you need to do two things. One, you need to set up the surface view. And two, you need to draw to the surface view that you just set up. Let's talk about each of those steps one at a time. To set up the surface view, you first use the surface view's getHolder method to acquire the surface view's surface holder. Next, you register the surface view for surface holder callbacks by calling the surface holder's addCallback method. Now these methods are one, surface created, which is called when the surface view's surface has been created. Until this method is called, you can't draw on the surface. It's not ready. Two, surface changed. This method is called whenever structural changes, such as changing the surface's size, occurs. And three, surface destroyed. And this method is called right before a surface is destroyed. Once this method returns, you can no longer call operations that will draw on the surface. And the last setup step is to create the thread that will be used for executing drawing operations on this surface view. And remember that the surface holder callback methods will usually be called from the main thread, not from the surface views thread. So you'll have to make sure that you synchronize access to any data that is needed by both threads. So once you've set up the surface view, you can start drawing on it. To draw, you'll first acquire a lock on the canvas by calling the lockCanvas method. Next, you do whatever drawing operations that you want to do on the canvas, for example, by calling a canvas method such as drawBitmap. And last, you unlock the canvas, allowing Android to update the display. And you'll do this by calling the surface holder's unlockCanvas and post method. So let's look at a different implementation of our last example application called Graphics Bubble Canvas Surface View. I'll start up the Graphics Canvas Bubble Surface View application, and when I do, the application will start up and draw the bubble at a randomly selected location on the display. But this time, instead of updating every second or so, this application will try to do as many updates as it can. In addition, the application will also rotate the bubble view to give the appearance that the bubble is twirling through space. So here goes. And as you can see, the bubble is smoothly animating, both moving and rotating as it floats along. Let's look at the source code for this application. So here's the Graphics Canvas Bubble Surface View application, open in the IDE. Now I'll open the main activity, and in onCreate, this code again loads a bitmap from the resources directory, and then uses that bitmap to create an instance of a custom view class called BubbleView. Let's look at the BubbleView class. The BubbleView class extends Surface View and implements the SurfaceHolder.callback interface. The constructor for this class does a lot of housekeeping, and then down at the end of the method, there's a call to the getHolder method, which returns a surface holder. The code takes that surface holder and then registers this bubble view for callbacks. Let's look at what happens when these callbacks finally arrive. First, we see that when the surface for this surface view is created, this code creates a new thread and then starts it, and that thread's run method then goes into a loop. And on each iteration of the loop, it checks to see whether the thread's been interrupted. And if not, it then calls the move method, which, like before, moves the bubble view and returns a Boolean indicating whether or not the bubble view has left the screen. If these checks evaluate to true, then the code attempts to lock the surface holder's canvas, and if successful, the code then calls the drawBubble method, passing in the locked canvas. And then, finally, the application unlocks the canvas and allows Android to update the display. Let's go back for 1 second and look at the drawBubble method. Now, this method first redraws the canvas's background, then it rotates the canvas, and then it redraws the bubble on the canvas.